Hi everyone, my name is Vladislav and I'm iOS engineer at Algolia.
And hi, my name is Mouaad and I'm an Android engineer at Algolia.
And they are pleased to be here today to show you how to add Algola into a Flutter application. They both primarily focused on the native versions of our InstantSearch library available for iOS and Android since 2016. However, we have recently invested our time and effort in closed-platform technologies. Our team has developed React InstantSearch, which makes it much easier to build cross-platform applications using React Native. And today, they are proud to announce the alpha release of our Algolia Flutter Helper. It will be introduced to you today as a part of this live coding session. They observe more and more traction for Flutter among our customers. And we want to make sure we are available on stacks mostly used by our community. Before they move to the live coding part, let me quickly give you an overview of what we are going to build together today. So the simulator should be just here. And OK, let's go to the live demo. Our goal is to add a search experience on top of an existing e-commerce sample app. We'll focus more particularly on two screens. The autocomplete experience, the user can get query suggestion in real time at each on their keystroke. The result page from which user can easily explore the search result. And refine the set of results thanks to refinement sidebar. So they can sort row-hits and they can apply filters here. We'll see how to use this new Flutter helper streamlines the integration of Algola into the project. Please note this workshop is primarily made for developers with a previous experience with Flutter. We only have 90 minutes, and we will focus our attention rather on search and discovery than on the details of Flutter UI layout. We have made a boilerplate ready for you to use and follow with us. We move forward in the live coding so you can integrate Algolia by yourself. Obviously, we don't have time to set up the Flutter dev environment together, so they assume that you already have it in place. Introducing the simulator, including the simulator, regardless if that one is for iOS or Android, our demo might work on both of them. All right, enough presentation. I suggest we move into the building. I pass the word and control to Mouaad.
Hi again. First thing is that before we get any further, please keep in mind that this workshop is meant to be interactive. So if you have any questions, please ask them in the chat. We will take a few minutes each time to answer them live. If it's not possible, then we will do it just after the session. That was first. Second thing is we will be using, as Vlad mentioned, our brand new Algolia helpers for Flutter. There is, in fact, a guide in the documentation that shows how to create a Flutter app using Algolia and Flutter, of course. So this guide is already available. The link will be shared in the chat. So please take a look at it. The last thing is in a couple of weeks, we should include also in the same guide the use of the Algolia helpers for Flutter. So that was it. Let's jump right into it. Okay. So let's go to the first step, which is, of course, here we have the DevCon workshop boilerplate repository, which we will be sharing with you in the chat. I'm sure. Let's check if it's in the chat. If not, we will be sharing it right now.
Yeah, just here you push the button.
All right, here the chat. Oh, it's in the chat. Thanks, Alex. Thanks, Alex.
No, he shared the Algolia Flutter Helper, but he didn't share the...
here we go.
Yes, this is the guide, and this is the boilerplate. Right?
Here we go. All right.
So,
okay, this is the boilerplate repo. So what you want to do, of course, is to clone it to be able to follow with us all the steps and the workshop. So to do so, of course, what you need to do is so
I think it's on the left. Yeah.
Here we go. Git clone, and of course, simply clone the repository. Of course, we already did it. We already cloned the repository and opened it in our IDE. Please do so also if you wish. Meanwhile, I will explain a few things about the project. The first thing is that we have a few branches. Each branch corresponds to a step in our workshop. Each time we will say at which step we are. If you feel that you are behind, please check out to the corresponding branch to follow with us the workshop. The second thing is, if you open the boilerplate project in your IDE, typically Android Studio or IntelliJ, in that case, you can have the
this is
the repo. So you will there is typically to do view that allows you to actually follow with us everything we do. You can just take a look at this and see at which step we are and follow with us. Okay, enough talking. Let's jump into the code.
I think you have to start the index presentation.
Yes, exactly. Before going into the code, we will need also to have an index already available. For our case here, it's
here.
just here. We need an Algolia index, of course. We will need the application ID, the IPA key, and so on. In the project, everything is already set it up for you. If we look here at the project, we actually have everything already there. So we will be using this index for the whole workshop. Okay, so let's start. Our main entry is the main.dot file. So before going any further, what I'm going to do is just run the app and see what happens. And as you can see, for now, nothing is happening. We have a UI, static UI. There is no search, no nothing. Okay, let's explore a little bit this before implementing our search experience. Okay, the first page, which is the home screen page, we can click it right here, check it right here.
I think, sorry for interrupting you, before moving forward, they have to speak about the dependencies and to install dependencies,
True.
because otherwise your project won't be
exactly
usable.
Exactly. So for the dependencies, there is actually a few. The first one we already talked about before, which is the Algolia helpers for Flutter. This is the one that provides us all the components that we will need to build the search experience we want. These two things, these two libraries, the first one is for pagination, simply to have paginating experience while scrolling over the search results. And the last one, which is called provider, this will simply allow us to share logic between screens. That's it. Okay, of course, if you are familiar with Flutter, you need to get all the dependencies with Flutter, pub, get, and so on. Okay, or just click here in the button here, and you will get the full dependencies. All right. Okay. Going back to the home to the home screen. I don't know if you can see. Oh, okay, everything's good.
Works well.
Yeah. All right. The home screen. The home screen have a few sections here. Of course, everything related to UI is in the build method. We have a few sections.
Actually, before they continue, I propose you to put the simulator here on the right side,
Yeah,
so
good idea.
they can see what happens here. Yes.
Thank you. We have the Algolia up bar, which corresponds to this upper bar here in the screen. This is a static UI. We won't touch it. The other part, the second part, is the search panel view, which corresponds to the search bar and so on. This one we will see it later. And the last part is just simply a single child view scroll view, which contains a static banner view, and more importantly, the two products view. So what we want to do here is to send a request, a query to Algolia, get the list of products, and display them there in the screen. Just to get familiar with the tools provided by our helpers, we will start by just statically sending a query that we provided before and display it. Let's just do that. As you can see here, there is nothing is displayed. We have this infinite circular indicator. Why? Because in our case here, what we return is actually just an empty stream. By the way, we will be using streams here to display results. Why we do so? Because we expect to have multiple results each time, and we want our UI to react each time we have new results. So what we want to do is to replace this empty stream by the stream of actual hits from Algolia index.
Yeah, product hits.
Exactly. So let's start by creating our first component from the Algolia helpers, which is called hits searcher. The hits searcher is the component that allows us to send a request, send a query to Algolia, and get a response, or for our case, multiple responses each time we update our query. So let's just go with that. Let's start with that. We have hits searcher. Let's name it searcher. Choose searcher, because actually we want to display list of shoes. So let's just do that. Credentials. We will need our application ID. Then we will need our credential, from our credentials, our API key, and at the end, credentials dot hits index. All right. We will update this later on, but let's just start with that. All right. So we update here the stream. Our components hit searcher have a field called responses. So what is this field? This is the stream that returns the response we receive from Algolia each time we have a new query and each time the search state changes. So there is two concepts here. Let's start by the search response. Every time something happens, we update the query, we change the page number, for example, we add some filters, we will get a new response, and what we want to do is get those responses and display them. But to get new responses, we need actually to update the search state. And this is where all this methods comes in. For example, apply state takes a search state object, which actually, as I said before, the list of configuration or parameters we can pass to Algolia for our query. For example, we have a query string, a page, facets, and so on. So what we want to do here is to get the list of response, map this list of responses to to our object. We have response here. So we take each response have list of hits, and we will just map it to we have product dot from JSON, and we need a list here, and that's it. There is a way actually to simplify this. We can just remove this here and the arrow. That's it. So if we now run the example again, we have a list of products from Algolia. But what we want actually is a static query that we can pass in the first place and just display the results. To do so, our component have another factory method which is called create, which takes state, and we can just pass our initial state. The index is always the same, and for our case, we will pass a query, and the query should be just shoes. Everything here is constant, so we can just put const. And here we are. So let's run this. Now, as you can see, we have only a list of shoes that we actually want to have. That's the behavior we want to have. Okay. Now let's do the same thing for the other products list. Okay, so let's just do that. I'm going to name it seasonal products searcher. Like that. Credentials app ID, credentials IPIT, and the end credentials. It's index. Okay, for this one, we will use what we call a rule index.
It's rule context.
Rule context. Sorry, maybe you wanna.
It's related to our feature, Algola engine feature called query rules. So it's just another merchandising feature. So you can read more about it in the documentation. But the idea here is just to get the subset, subset of the hits, which is marked as home spring summer 2021.
All right. This is another hit searcher. So what we want to do is simply
don't forget to remove the first to do, because it's not to do anymore.
It's done. All right, for this one, it's going to be exactly the same thing. We have our second searcher. There is a list of responses, a stream of responses. Each time we get a response, what we want to do is to get the list of hits from that response, hits, and then map those hits into our object.
So it's basically exactly the same logic as in the previous one.
Exactly. So you see here we need to list.
No, there is one.
Here.
Yes.
Here we go. Let's do this. Here we go. All right. We run and done. Now we have two queries actually firing up at when we go to the home page. The first one is getting the list of products for the query shoes, and the other one is the contextual one with the rule we specified here. And that's it. That was the first step. Okay, so before moving to the next one, maybe
let's check the chat. If you have any questions, so it's interactive. If you have questions, so all right, don't hesitate. We can wait a bit if you have any questions, ideas, maybe.
Yes. By the way, before moving any further, as we said before, we use streams to get the list of responses. Here, our streams are what we call hot streams or broadcast streams. That's why we can actually subscribe to those responses as much we want, get the data, and display it as we wish. There is also a method called snapshot, which allows us to get the current state of the search state. And we also have another stream that's if you want to react actually to the changes happening to the search state. This will come in handy later on, but this is important to understand. And at the end, we have, of course, the dispose method if we need to dispose of the underlying resources. All right, that was the first step. We will move now to the next section.
Apparently, we don't have apparently don't have any questions right now. So okay, so let's move forward. So as they said, they provide multiple steps here. So so let me terminal. It's like so if you did not manage to follow like all the steps they did, you can just switch to the step 2. So what we will do here. And so what's the problem? Yeah, I need to force it because they made some changes.
Yeah.
Yes, so it's okay. So now they have like they just switched to the state after the first step. So it's basically the same in our case. Okay, and let's move forward. So what do they see here? They have a search bar, but then they click here. Yes, actually search button. So then they have a search screen, and nothing happens if we type anything in the search bar. So this is the autocomplete screen, and here they want to see the list of query suggestions for a search. So I'm pretty sure you already saw like autocomplete experience with query suggestions. So it's especially important on the mobile because you have a small keyboard, so you don't want to type a lot. You want to type just the beginning of the word and you have a list of suggestions. So you can either select the search query or complete your query and to complete it by yourself, but and to move forward. So how the suggestions are organized at Algola. So basically, they have just a specific index. So just like a normal Algolia index here. So it's automatically generated by Algolia. So you see here, they just have like a records in a specific format. So they have a query, which will be a result of our search response. And they have a popularity to rank them, to rank the search results. So then I type something. So I get the highlighted results. And this is what we want to achieve in our small mobile applications. They also want to get the list of these suggestions and to present them in the highlighted form. So let's move to the code. Let's move back to the code. So we start with. So let's switch to autocomplete screen. So this screen is, so it's a scaffold. It uses scaffold widget. It contains a custom scroll with the 3 sections. The first one is the search header. You see here with the arrow back button to go back, and the search header view. There they can submit a query, but as you can see, nothing happens here. Then they have a suggestions header. It's just like a text popular searches, which is embedded in the stream builder because they don't want to show it if the list of suggestions is empty. So here they get a list of suggestions, and if it's empty, so they present an empty view. Otherwise, they present just the text. And the third one it's also embedded. It's the suggestion body, so it's basically the list of our suggestions. So it's also embedded in the stream builder because they don't want to show anything if the list of suggestions is empty. So here's the list. It's liver fixed extent list. So they build they build a suggestion row view for each suggestion, and then then they push the complete button. So they call the complete suggestion method of the suggestion repository. And let's move to the suggestion repository to see what happens here. So the suggestions repository contains the text editing controller which handles our search input field. Yes, let's start to fill it. So as I said, suggestion index is just a normal Algolia index. So they can just use the same component as they used for the product search. So it's a hit searcher. So let's call it suggestions searcher. We fill it with credentials as well. Credentials. Application ID and credentials API key, and finally we just target another index, which is our suggestions index. So it's as I said, basically the same component they used for product search. Now. So they had the search, but so they want to launch this search on each keystroke. So then they type something here. They want to launch a search query. So to do this, they just call the query method of our searcher, and they pass the text we have in our search text controller. So I move back to the autocomplete screen to explain you better. So then they build our suggestions header. Sorry, not the suggestion header, but the search header. So they pass the search text controller to our search header view, so they can handle the state of this text field. And let's move back. So here they launch the search request. Let's remove it. And finally, they just do the same thing as they did for the products. They want to parse our hits in our response to a list of query suggestions objects. So what I do here is I get suggestion searcher responses. I also extract. So here is the response. So they get hits from response. Hits. And then they map it into our query suggestions object, which already contains a query suggestion object, which already has a convenient from JSON method. So yes, I forgot to transform it then to list because by the end it's just iterable. Well, so that it's done. Yes, it's all good now. So they get, so they added a searcher. So they listen to the change of our text field, and they provide the list of suggestions in the result. And also here is the complete suggestion method I showed you. So let me show you the experience. So I think
you need to rerun.
Yes, I have to rerun the project. So
that doesn't work, but we can just stop the app and restart it.
What's
we did before? Sorry, can I help?
Yeah.
So build.
No, it's in the run.
You can just stop it.
Yes, let's stop the app and run it again. Wait.
Yes.
And so here
it will take a few seconds.
It'll take a few seconds because the
hot
reload doesn't work.
Yep. Maybe we can look if there is any question meanwhile.
Yes.
Questions meanwhile.
Good idea. Let's check the questions.
Not yet.
Not yet.
Please don't hesitate to ask any questions if you have. We will be more than glad to answer them.
Okay, so they have something unexpected. So they have
maybe something is important. I saw something.
Okay.
Not sure what the
Yeah.
with
So
that
they
this
can
can just delete that line.
just remove this line. Yes.
Yeah, let's go. All right. So as we said before, here we are using again a hit searcher. That's the component that's
Okay.
it's working.
Yes.
All right.
It compiles. Okay, great.
Yay.
So yes, they did it. Okay, so it's a live demo, so the issues happen.
Yeah.
So let's type. So yes, it works as expected. So they can so they see the list of highlighted results, and then here's the complete button. So then they click it. It doesn't launch the search, but it just complete our request. So as you can see, that's it. But maybe you might not you have noticed that the highlighting here. So this is like the normal highlighting behavior, but from the user experience point of view, for the search suggestions, they are not interested to highlight the part we already typed. They want to highlight the completion part. So basically, they want to invert our highlighting, and it's extremely easy to do. Thanks to Algolia Flutter Helper. So to make this, let's open the query. So in the model, the query suggestion file. Yes. So here they have the query suggestion contains the string query, and also it gets the highlighted string. So highlighted string, it's the component of Algolia Flutter Helper, which simplifies the highlighting logic, which is simply to use the rich text Flutter component. And so here they have a hit model here, and here they have a convenient method get highlighted string for a query, but they can get a highlighted string for any field of your record. So here's the case for the query, and then they want to invert it. We just set inverted here to true. And that's it. So I just did hot reload, it worked. So as you see, they have the completion part is highlighted now. So this is exactly what they expect. And that's it. So they have a autocomplete experience. If you have any questions, so let's check the chat.
All right.
Okay, we don't see any questions so far. So let's prepare the next step.
Yep. All right. So here in this step, we used again our components, the components hit searcher for running search requests and getting suggestion. But now what we want to do, it's once we have our query ready, we want to send this query and get the actual search results. Right now, if we click, nothing actually is happening. There is no query, no hits, and nothing displayed. So what we want to do is to fix that. All right. To do so, first let's switch to the step tree step tree branch. If you didn't manage to follow with us until now, you can just do that. So I will do it. Check out step tree, and okay, ready. All right. The search results screen. This screen, the code, the UI is available in the search results screen.dart. As you can see here, we have again few sections. We have the upper part. Of course, there is always the up bar right here. Static one, the static UI won't need it, but there is two sections that we want to fix here. The first one is related to metadata. We want to display the query we selected from the auto suggestion from the autocomplete, and the number of hits that we can find from in the response from Algolia. That's the first one. And the second one is actually the actual list of results. All right, let's start by the first one, which is the metadata. Okay, here we have a repository that we called search repository, and if we look into it, we have a stream. This is a stream for now is empty. Nothing, it displays absolutely nothing. So what we want to do is to create, since we are going to do again a search operation, so we will need a hit searcher, put the query on it, send this query, get the results, display the metadata and the results. So let's start with that. First, let's do the hit searcher. I will call it products searcher for the credentials. I will use the credentials of my index here, the API key, and final part is the hits index. All right, now I have my searcher. The next step would be to get the query from the autocomplete and send it using the product searcher. All right, let's do that. We are at 3.2 here. We have a method that called search. We will set our query here. We have a convenience method that called the query. We will just use it, and that's it. Under the hood, this query method will do exactly the same thing as we did before. Take a search state and update it with our query. All right, this is done. When now we want to get the results, the search response, and get the search metadata from it. To do so, our responses are available in our searcher. So let's do that in the responses. Then we want to map those responses, get each response and map it from each response have hits. By the way, in our case here, here we have what we have is we actually have created before a convenience method that will just take our search response and build for us our search metadata. So let's just use that.
And just a sub view of our search response. They've a query and they've some meta information like the query they sent and the number of hits.
So we can just use that. And done. Okay, let's run this and see what happens. Here we go.
Not sure if hot reload will work here.
Okay, that's okay. We will just do it manually.
Classic.
Run.
Yeah, just select the.
I don't want to run it as debug. Just run hot reload, but just go for run. That's okay.
Yeah, it's okay.
That's okay. Okay, it's
pretty quick.
Yep. All right.
Almost like hot reload.
So we have jackets. We have always the autocomplete working. We click right here, and as you can see, we have our query here displayed and the number of hits. We don't have the list of products just yet, so let's do that. Of course, the list of products is lives in the responses that we will get from Algolia. So let's just use the same searcher again. Responses. Since the responses stream is a broadcast stream, we can listen to it multiple times without an issue. So let's do that. Map for this class. We actually again prepared a utility factory method for it, so we can just just get our products page. This one simply gets the list from the response, gets the list of the hits, and then check if we are at the last page. If yes, we don't request the next page. If not, we just stop there. So we will just use that. All right, we will use it here, and we run. Auto reload, please. Okay, now let's go jackets, and here we go. Now we have the list of of products from Algolia index, but we have a small issue. We can't for now. We don't display the next pages. To do so, what we want to do is to use our paging controller and add to it, and add the listener that fires a new
page request
at when we scroll, and append the result, which happens actually here. Append the result into the paging controller. Okay, let's do that. Our searcher, we can use always our searcher to do that. What we want to do is take the current search state, and what we want to do is to update it with the new with the new page number, which we have here. Let's do that. Okay, let's now run the app, and now if we check jackets, now let's scroll. Now our scroll is working as expected. So what we did right now is to add the hit searcher to the search result screen. Add the query we got from the autocomplete to the searcher, display the list of results, and add the logic to update and request new pages to add the infinite scrolling behavior to the app.
The Algolia search is so fast that you don't see in the loading the spinner. It just works smoothly.
All right, that was it for this part. Let's see if there is any questions before moving on. Not yet. Please don't hesitate to ask them. We will be more than glad to answer them. All right, I think we can move to the last part.
Yes, and the last part, and one of the biggest one. So here they have a list of results, but then they click the filter button. So they see certain brand headers, but yes, even if you click, they see the list of sort orders, and they see nothing in the brands. So we will implement this script. And before we start, let me explain you how the sort is organized at Algolia. So to implement the sort, so sorry, I switched to, yes. So to implement the sort, they just target a different index. So in our case, so they have this as our main index, the ecom products. Sorry, this is a query suggestions index. So this is the products index. And so to implement the sort, they just create the replica indices with different ranking formula. So here they have another index which contains exactly the same set of products, but the different ranking formula. So the receiver products in price, the products with increasing price, and same thing, but for the decreasing price. So what they need to do to implement sort is just to change the index they target in our search, and that's it. So let's do it. And before they start, so you can move to the step. So if I'm not mistaken, it will be a step.
Step 4.
Yes.
Step 4.
Step 4. The fourth step 4 and the fourth.
Here we go. All right.
Yes. All right. So let's check if everything is okay. Let's go to our filter screen. So it contains. So here they have in the state of our filter screen. So let's increase it a little bit. So they have the map of the indices titles. So this is the mapping between the index name and the title we want to show in the UI. So you could see that they have the most popular, price low to high, and price high to low. So this is the static part. So then here in the screen itself, so it contains like the header, the filter and sort header. Then they have two sections. The first one is like sort header, so they always show. Then they have a conditional part. So this is the sort selector. So they can toggle it, and same for the filtering part, but they will do it later. So what they want to show? They want to show the currently selected index here in the header, so they can see which index they are targeting right now. And in the list of indices, they want to highlight the index they target as well when they open this section. So let's move to our products search repository. Yes. And so they start by getting the selected index name. So they can fetch it from the search state of our hit searcher. Basically, they get our product searcher, and they get state, and then they map it, and then they get the state. So they get the index name of our state. And here they are. So they get so they just transform they map our state of our searcher to the string, which is the currently selected index. So let's okay. So do you see it? So they have that the currently selected index is most popular, so it's highlighted, and they even show it here. So the currently selected index. Now, then they try to select another index. They can see that the list of results is refreshing, but they don't see any changes. So just refreshing it launches the request, but it targets the same index. So they want to change index on the next step. So let's implement the select index name. So to do it, they just need to update our search state. So they do apply state. So this is the same thing as they did the query. So they updated the textual query of our state and they get the instant result. It works exactly in the same way for the indices. So they just get a state, copy div, and they set the index name to the index name we just passed. And let's compile. Okay. So here, let's try. Okay, you see. So here they get the. Then they scroll. They see the prices increasing. And let's select another one. So they see the products in the decreasing order. And that's it. So they got. So they implemented literally two methods to implement the sorting. But let's move forward to the filtering. It's a bit more complicated. So let's move back to our index, our products index. So as you can see, they have a lot of fields for each record in our index. So and the field which we want to target is the brand. So as you can see, each product has its brand value. And in the settings on the index, it's added to the attributes for faceting. So that's why they receive, so if they add in our search state, if we add in the facets property, they add the brand attribute name. So we will get the facets that they can like facet filter, they can apply. So that's what they want to implement. And let's let's go. So as you can see, like this section is doesn't really work.
Empty for now.
Yes, empty for now. So, and let's start by adding the filter state component. So, let's start the final filter state. It's simply just as simple as that. So here they have a filter state. This is just the component which contains your filters. If you already worked with Algolia, you know that the filters parameter of our query is just a string. So it's a string. It's okay, but if you want to modify it to just toggle a filter or add filter or remove a single filter, it's not convenient at all. That's why they implemented this filter state. What they have in our filter state? So they get a stream of filters. So they have a free 4 types of filters. So it's a facet, tag, numeric, and hierarchical. You can read more about it in our documentation about the filtering. And you have a convenient API to add add filter. You also can group them. So you have a group IDs there, and you can replace all the filters using the set function. You can remove one filter, you can remove group, you can toggle filter, or check if the filter state contains any specific filter. So that's the purpose of this component. So it will contain, so then the select facet filter in our UI. So this facet filter will be added to a filter state. It will communicate with our searcher, so it will update. It will generate a correct filters value, correct filter string value for hit searcher.
Yeah.
Yes, and it will launch the search immediately with updated with applied filter. Let's move back to our search repository. So they added our filter state. So now it's time to add the Facet List component. So I'll add it, then I explain it. So it's brand Facet List. So it's a Facet List component. So they might pass the searcher parameter. So it will be our hits, our products searcher. Then they might pass the filter state. And finally, they should specify the attribute that you want to target. So in our case, it's a brand attribute. So they put it here, but so they have a warning here that the instance member cannot be accessed. So that's why they have to declare it as a final. Yeah. Oh, sorry, late. Yeah, final. It's already final. Final and late. Yes. Okay. So what's the Facet List? So Facet List, it's a component which handles the presentation of the list of facet filters. So then you launch a search request and you provide in your search state, you set the facets parameter. So you set brand. So you get the list of brand attributes and their values that you can apply to a search. Basically, this component will store these facets that you receive from the searcher, and also it will show the selection state of each facet because it's connected to a filter state as well. So it also provides a convenient API to they can get the stream of facets. So it's a list of selectable facets. Selectable is just a wrapper of selectable item. So they have a facet object and they have a associated flag if it is selected or not. And it also has a toggle convenient function which selects our filter if it's not selected and deselects it otherwise. Okay, so I described you how it works. But as I said in our search repository, so then they instantiate our Facet List component. So it's connected to product searcher and filter state, but the product searcher and filter state, they are not connected. They are not interconnected. So let's fix it. So here they have so it's a product searcher. You have a convenient filter state function, and that's it. So now they establish the connection between these components. So each time they update the filter, so it will trigger a new search in the product search. Done. So the next part, so they want to get. So now on each search they get the list of facets. So basically, if I relaunch the search, I get the list of facets, but I don't see here anything. Why? Because I don't my brand facet streams, which I used to build this list, the list which might be here, it's an empty stream. So let's replace the stream. So for this, as I showed you, so they have just a facets getter to get the brand facets. Let's update. Okay, they get the list of facets, and they see they're all not selected. So they can select them, but nothing happens. Why? Because then they toggle our brand. They just update our paging controller, like refresh it to reset the loaded products page. That's why they see like the hits updating, but they don't toggle our brand value. So let's fix that. So I forgot to remove the to-do here. So here they have a brand facet list. We toggle it. We pass the brand. Let's save. Let's check. And it works.
Yeah.
You see, I selected Montclair. It works. Then I selected Michael Kors. I think I have to something went wrong. I think to rebuild.
Yeah.
Yes. So
just close.
So it's like this. Okay. So let's try once again. So I apply the boolean. So I get the boolean.
Yep.
And then I apply the Invicta. I deselect boolean. I get just Invicta products, and this is exactly. And I can select multiple products, and for people who already tried to implement disjunctive faceting, the Algola, you know, it's not trivial, and our helper manages the complexity of disjunctive faceting for you. So you don't care about anything. You just instantiate components, you interconnect them, and it works. It works like a charm. So great. So they completed our workshop.
There is a last.
Yes. There is a last step. Yes, the step I missed. So it's not obvious because like I will demonstrate you what did they forget. So for example, you selected the facet here. So then you move back and you select another thing. You see you have no results. Why? Because they still have a selected brand. So they didn't reset it. Then they closed the screen. So that's the issue. That's why they might clear the applied filters each time they exit the screen. So you see, then I enter the jackets query. It was the same one that I filtered previously. So I see the brand facet applied. So it's still there. So it didn't disappear. So what the missing part is to call so it's actually to clear our filter state. So to do this, we just call filter state clear, remove it, and let's try again. So I apply. So here I have the filter applied. So let's apply like multiple filters. Let's move back. Like no filters applied, they see everything, and let's move back to the same query. They get all the result, they see no filters applied. So they are all done. So let's move back. So they have the home page with the static results list. They have autocomplete experience with inverted highlighting. We have a results list with some metadata and sorting and filtering functionality that we built just in 1 hour. Of course, they just built the logic, not the whole UI, but without the helper they provided, it would take way more time. Just believe me. So congratulations, they are all done. Together, they just integrated Algolia in the e-commerce template app. If if you already tried to build this kind of UI, you might appreciate how much easier it became. Of course, we keep available the boilerplate repository, so you can go through all the steps on your own and do it like in a quiet environment in your RIP.
By the way, there is a branch called final that you can use and get exactly the final result.
Yes.
Here from the.
So if you do get checkout final and the Facet, so they get the final branch, and it's just like exactly the same state as they have in the end of this workshop. So they are good. So so let's. They also encourage you. So let me show you the e-commerce. Yes. So they have here the documentation for e-commerce template. They encourage you to check it out because it gives a way more detailed overview on the project and includes some part they didn't include in this workshop for the sake of brevity. And they have a few minutes left to check if they have questions in our live chat. Let's check it out. Okay.
All right.
So they have they see one
thank you, everyone.
Yeah, thank you, everyone. They have just one comment, like people. I hope it's like an impressed smile. Hopefully, it was really impressing. And so thank you. So thank you for your participation. So thank you for joining. You can see our contact information on the screen. If you have any question, idea, or anything you want to share, please don't hesitate. You see like our email address, LinkedIn, Twitter, whatever you prefer. Don't hesitate. And so you have a time for a small break and before the closing session of the DevCon. Thanks for joining. And they can wait a few minutes. Maybe any questions appear in the end. Okay, so no questions, just reactions.
Yeah.
Reactions.
Thank you, everyone.
Thank you, everyone. So
bye-bye. Thank you.
Bye.